Okay, we're going to sketch these two graphs now. F of x is minus 2 sine 2x, and g of x is cos of x minus 60. If you know your theory about graphing trig functions, that little 2 changes the period and the step. Instead of a period of 360, which is normal for sine, it's 360 divided by 2. It's 180 degrees to go through a complete wave. And the step should be 45 degrees. That minus should turn a regular sine graph upside down. So instead of going like up and down, like that, it'll go down. So anyways, it turns it upside down. And this is a cosine graph. Both of these go between 1 and minus 1, but this cosine graph goes 60 degrees to the right. Well, let's see what it looks like between minus 90 and 180. Well, there it is. There's your sine graph. It goes through 0 and 0. You could put in 0. I don't like doing the whole thing in the calculator. It's better to understand it. The 0 there. If you put in minus 45 degrees, the cosine of that is minus 90 is minus 1, but the minus makes it plus, so that's why it's going up here. So at 90 degrees, minus 90 degrees at 0, then it goes up to 1, then back to 0, down to minus 1. So it rocks between 1, 0, and minus 1, and then comes back here. Every 45 degrees, something happens. Now you've got to label these turning points. You don't have to label this. There should be 180 degrees there, and minus 90 degrees. That counts as a label. And you just have to label the function f. And there's that one sketched. The other one, you have to know that cosine of 0 degrees is 1. And then it goes right at 1, and then it would go to 90 degrees. Except this one is shifted 60 degrees. So it starts at 1, and then 90 degrees, it goes to 0. That's the step of a cos graph. So at 90 degrees, it goes to 0. If I add 30 more in there, go put 180 degrees in there, and go the cos of a minus 180 minus 60 is 120. The cos is negative a half of 120 degrees, and that's your endpoint that you got to graph. If you go 90 degrees back here, it gets to 0. See, at 60, go all the way to minus 30, it goes to 0. And then just put in minus 90 degrees, and you'll see it's minus root 3 over 2, or minus 0.87. That is the endpoints. And there's the sketches of your two graphs. Now, those answers for where they cross that we did, look, that's minus 10, and that's 110 degrees. Let's try the last question. Determine the values in between in this range from minus 90 to 180 for which f of x, this means, is less than or equal to g of x. So in other words, they're asking, and I'm going to use this a little annotator to help here. I'm going to make a line. Oh, I'd like to make a line. Maybe I'm going to have trouble making a line. I guess I am going to have trouble making a line. Maybe I'm not. Oh, I am going to have trouble making a line. Okay, if I had a straight line, you got to imagine I've got a straight line right here, and I'm passing this straight line right through here. This, wherever I stop, like say I stopped right here, look, F is below G. The green line is below the red line. All the way here. Look, the green is below the red, the green. Now they're equal. So at minus 110 degrees, they're equal to each other. And at 110 degrees, they cross and they're equal to each other. But anywhere in between here, the green line is below the red line. That means that f is less than g of x. When x is less than 110 degrees, and it's greater than minus 10 degrees. And that's the solution that makes this statement true.